All right, happy week 4 of remote virtual learning. It's been a while since I put my face on one of these videos, so I figured might as well go ahead. Y'all can see what this looks like without being all done up for school. All right, so we are going to kind of get started with our largest invertebrate phylum, which is the phylum Mollusca. And I love this image from SpongeBob just because it kind of shows you the wide range of the types of organisms that we can find in this phylum. So anything from a squid, an octopus, all the way down to a snail, a clam, all of that falls within that phylum Mollusca. All right, so just some general information. Like I said, this is the most abundant phylum in the ocean. So it is our largest phylum in the ocean. All of our organisms within this phylum have that bilateral symmetry. Remember that that means that it is equal on either side. It is divided into two equal parts. And they are all organized at the organ system level. So we started out talking about sponges that are organized at the cellular level. We then talked about cnidarians like jellyfish and corals and sea anemones that are organized at the tissue level. And now we're kind of going on up to our most complex organisms that are organized at the organ system level, meaning that they have tissues that build organs, and then those organs all work together to form these different organ systems that keep these things alive. All right, and this is the most abundant phylum in the ocean because it encompasses so many different types of organisms. So it can include snails, slugs, clams, mussels, oysters, squid, and octopuses as well. All right, so when we are talking about our phylum Mollusca, basically all these different things that I mentioned in the last slide are all kind of organized in the same type of way. So they all have this soft body that's enclosed by this calcareous shell. And if you remember back in Unit 3, we said the word calcareous a lot, and that just means that it's composed of calcium carbonate, so that's CaCO3. All right, so these organisms are all covered by a structure referred to as the mantle. And the mantle is this thin layer of tissue that actually secretes the shell. Now, when you think about things having a shell, normally you think about clams and oysters and scallops having shells, but our octopuses and our squid actually don't technically have a shell. And we're going to talk a little bit more about what that looks like as it differentiates between the different classes found within the phylum Mollusca. All right, so all of these mollusks do have a ventral muscular foot that is used for locomotion. So this muscular foot is what helps them to move around. We're going to look at class Bivalvia first, which is our clams, our scallops, and our oysters, as well as our mussels. And we're going to talk about what their foot looks like and then how that foot is then modified into our class Cephalopoda and our class Gastropoda, which is our snails and our octopuses and our squid. All right, so all of these organisms do also have something referred to as radula. And radula are just basically these rows of small scraping teeth. So you can think about it like kind of like a sandpaper tongue. So the tongue actually will rub back and forth across the food and it will start to break it down. That would be basically like you licking something and you having like razor sharp tongue. So it kind of scrape away at that. All right, so looking at some of our different structures. So this is a anatomical diagram of what a inside of a clam looks like. And I'm going to go through and kind of talk about that when I can actually get my hands on a clam in the classroom and video that as well. All right, so we've got a cowrie shell over here, which is an actual animal very similar to a slug or a snail. And then we have the beak of a squid right here. Actually, this is an octopus, but this is the beak structure found on octopuses and squids. And we'll look at that when I do the virtual dissection of the squid as well. All right, so our very first class of mollusk is actually our class Bivalvia, and this means two-sided shell. So whenever you hear the word bi, you need to think two. Whenever you think valve, you need to think basically sided, okay? So Bivalvia means two-sided shell. So these would be things like your clams, your oysters, your scallops, and this entire body is going to lie within the mantle cavity. So if you take a clam and you open it up, it's got a thin layer of tissue that actually sits on the inside of the shell. And that's what that mantle is. That is what's secreting the shell itself. All right, so it does have these super strong muscles, these anterior and posterior adductor muscles, and that's what's going to help to close that shell and keep predators out. Bivalves are filter feeders, which means that they use something referred to as a siphon. So you've probably heard of somebody siphoning gas, and that's taking a tube and taking something, a substance from one place and kind of transferring it to another. This is basically the same concept that bivalves use in order to feed. All right, so we have these two siphons. We have an in-current siphon and an ex-current siphon. So this in-current siphon will bring the water in. The food or the water will be kind of filtered out through the gills, which is weird to think about. So the gills have are serving a dual purpose in our bivalves. So they actually are used for gas exchange and for feeding. All right, so that water comes in through the in-current siphon, gets filtered out by the gills. All these little organic particles get stuck in there, very similar to the way that a sponge kind of filter feeds as well. And then that excess water is moving out through the ex-current siphon. All right, so here's a lovely picture of a scallop. So this is what a scallop looks like. We've got our adductor muscle, which is what is helping to keep the shell closed. We've got our gill structure here. And I don't know if y'all can hear my dogs. They just started barking in the other room, so I'm gonna try to talk a little bit louder than them. But we've got our adductor muscles, our gills, our mantle right here is what is secreting the shell itself. We've got our gonads, our sex organs down here. Our liver is going to be the dark spot at the top of a bivalve. And then scallops are actually kind of cool. They have what is referred to as eyes, and we refer to them as eyes. Primarily, they're more photoreceptors, so they can basically sense light. All right, so a little bit about bivalve behavior. Bivalves are burrowers, meaning that they are going to use that muscular foot to actually bury themselves in the sand in order to keep safe. And the majority of these do attach to a substrate, but oddly enough, some of them do dig into the sand and kind of stay down there as well. And then scallops can actually swim, which is weird. So I'm going to link a few of these videos that are in the PowerPoint presentation. It kind of gets messed up when I try to play it on the screen and record it. So I'm going to link all of these videos below as well, and y'all can watch them on your own time because they are really, really cool. And I will say this is one of the funniest videos, this razor clams. So I strongly suggest that you watch that one as well. All right, so some of them are attaching to that substrate. And then some oysters actually secrete calcium carbonate, which is used to coat an irritating particle such as a piece of sand or dirt or something like that. And that's actually what forms pearls. So if you know somebody, your mom, your grandma, whatever, has a true pearl, that is actually, let me think of a nice way to say this. It's basically an oyster booger. So it is something that coats an irritant that basically keeps it from scratching up and irritating the inside of that oyster. And so they secrete these calcium carbonate covering in order to make it a little bit smoother, so it's a little less irritating to the bivalve itself. All right, so some scallops, like I said, can actually swim. This is one of the coolest videos I will ever show. Like I said, it's kind of hard for me to play it, but you know what? We're going to try it. Nope, we're not. All right, so I'm going to link it in there. I'm going to link it in there. Oh, there it goes. Check out that little scallop swimming away. Is that not the coolest thing you've ever seen? All right, we're going to get it to swim again. And there he goes. Swim, swim, swim. All right, so these scallops actually move by using jet propulsion or spitting. So this link right here, I'm also going to put in the activity for today so you can watch that as well. They will take that water in through their in-current siphon and then push it quickly out through their ex-current siphon. And it looks very similar to spitting, which is what kind of helps them to move through the ocean as well, which is really neat to think about. All right, so I am going to end on that note for class Bivalvia. Here's one of my funniest pictures. I do love this one, a little play on Jaws there. And then I will pick up the videos with our later classes a little bit after this one.